Okay, this is old electronics fan, and this is my realistic STA-2250 AM/FM stereo, and it's on the bench because it has well, it has one problem, but there are two issues causing it. When you're playing phono, and these are the stack of controls that control the different functions: phono, aux, FM, AM. Well, this control for sure doesn't work well, because if I try to play a phono through this, one channel doesn't work right, but the balance control is also dirty. So I'll be taking it apart to deal with that. The other thing that I will be showing you, and this is a repair I did previously, has to do with the power switch. I don't know how many of these were built. It's not a high-end stereo. It's actually a very nice sounding stereo. I think it's about 65 watts per channel. So it puts out quite well, and it can definitely produce a whole lot of sound. Like, you do have to be careful. Our daughter, I mentioned that she took out the tweeters in some of my speakers by cranking it too loud. But anyway, but one of the weak areas of this thing is the on-off switch. The switch in this had failed. It basically stayed on, and you couldn't turn it off with the switch. So I'll be looking at what I did for that. So the next thing you're going to see is that I've this thing all apart, and we'll get into the switch repair, and then I'll get into the relay afterward. One of the problems that you'll encounter with these old electronic stereos and other electronics, I suppose, is that the switches start malfunctioning. I had cleaned some of the controls on this. I had it apart before this. I think I did. But I didn't do these, and you'll notice something. These are completely closed. Now, there is a way to get these apart. You get a screwdriver on this side and a screwdriver on this side. You pry them apart. You lift the top up, and then you can shoot it with the cleaner that you want to use. I actually took these completely apart, and when I did, I discovered the corrosion was so thick that it was probably unlikely that my cleaner was going to do much, at least not anytime soon. So I actually used a small jeweler's screwdriver to clean the crud off. Now, one of the ways that you want to test these, and my favorite way of doing it, is using a decent analog voltometer. This happens to be my VTVM. One thing I really like about using an analog meter like this, and I've got a couple more around here, but unfortunately those have been so badly abused over the years, because I used to use them 40 years ago. And unfortunately, they have had close encounters with the floor on occasion, and both of them are held together with tape because they're just beat up. So they're not any good really for doing something like this. So what I've done is I've hooked up some small alligator clips to my meter, and I need to find out which one of these two I have worked on and which one of these two I haven't, because I put this aside to work on something else, and these got shuffled around, and now I have no clue as to which one is healthy. So here's what I'm going to do. Right now, these are the normally closed connections, and if I move this, you can see a little reaction there. That makes me think this one's the one I did not clean. Let's see. So now I'm going to push this in, because this was failing me when it was in this position, and it looks like it's behaving pretty well. Let's check the other side and see how this is doing. Because if this is not healthy, you'll see the meter dance. Because right now I'm just jiggling the stem in and out, and it looks like this is probably the one I cleaned. If that's the case, then this one should tell us or show us that it's not happy. Obviously not all the controls are in the same condition, but let's see what we got here. Now you can see the needle dance a little bit as I move as I move this in and out. And one of the downsides to an analog meter, I just turned it on, and I probably should have waited, but this will drift until it warms up. Let's see how we're doing here. And if I had been patient, it probably would have ultimately zeroed itself, and it would have been happier. I want to do this. But anyway, alright, so there we go. This is in. That's where that belongs. And you can see this is not real happy. And I can double check. Oh, come on. Oh, why are we not? Let's find out. Are we there? Okay, so that is fine. So put that back there. Put that back there. And now, apparently I had a bad connection on this. But as I move this in and out, you can see it dance. And it seems to be getting better as I work it. So maybe this one is not all that bad. But the other switch, I move that in and out dozens of times trying to get it to behave itself while the stereo was still together, and it did not fix it. Well, let's check out this side up front. And this is, that's there, come on, stay. This seems very touchy. Is the other side the same? Let's find out. Boy, that's just right. It just trips immediately. Well, that one doesn't. Ah, I see what's the problem. My cheapy clips here are not gripping very well. But the result is the same. Alright, let's try another one. But I'm pretty sure this is the one that has not been cleaned. Alright, so we'll go to the same routine here. This has 6 pins on each side, which means that the middle one in each set of 3 is the common one. Here we go. Let's see how this does. Now this one, oh, fell off again. Alright. Now you can see this one dancing. So that's a really good sign that the contacts on this are not healthy. I'm curious about this side. Yeah. That one's pretty touchy. Let's see how this side looks. And you get off from there. Alright. And this one's doing the same thing. So I have to take this one apart. And I'm betting all of them. And I'm going to do it anyway, because this is not a fun job to get this all apart. So I'm probably going to do them all. But I'm just trying to get a sense of what shape these all are in. I didn't use these as much. These have different functions, of course, and the functions these handled were not used very often. Yeah, but you can see that dancing away. So we'll go back to the one that I have cleaned, and you'll see the difference in the behavior, because it shouldn't dance around on you like that. It should just work. Come on, let's go. There we are, I hope. Come on, let's see. So we're gonna, and I can move it from closed all the way open before, and then that needle only moves when I actually open the contacts completely, and then they and then they of course respond. And get you there. Let's see how this side is. So I did a good job cleaning this one because it's behaving like a model citizen. So this is going to be how they will all work when I get done. But I wanted to show you why these old analog meters are so useful. And you definitely want one that's in healthy condition. Let me show you this poor old thing. And back in the day, Radio Shack was the place to go to get all your electronic needs, and I've got this old tired beast. As you see, the tape holding it together. It might be just fun to show somebody. What did I do with that one? Do I have that somewhere? I have a very old Micronto. There it is. This is my old, very old Micronto Bakelite case. And you can see this poor thing has really had a rough life. And the meter in this is no longer really functional. It doesn't want to zero out, it just doesn't want to work. So that one's useless. What I want to show you, because we discovered that these guys weren't working very well. And, alright, we're just going to do this for the fun of it. And I'll get on with what I'm going to do. And then probably come back. Because there's another thing I wanted to show everyone on this stereo. And I'll put you there. Actually, let's make sure that we're actually zeroed. Come on. Yeah, this thing goes where it will when it wants. And I'm going to just show you what I think this one has for a problem. Yeah, well, it's working better than I thought it was. Let's see. Get that out of there. Let's see how that works. Now this one's actually working pretty well too. And you can really see it. If the switch were in a little better shape, you might not be able to tell the difference, but you can definitely see it in this thing. I guarantee you the other old, very tired Micronto, you would not, this would not work. So forget that one. It's definitely too badly beat up. I may take the meter apart in that and just see if there's anything fixable there. But I will get back, because this is not a fun job. So when you pull this apart, the well, maybe I'll do that. I'll just take it apart and I'll show you what I'm dealing with. Let's see here. Alright, so we'll flip this around. We're still in there. Okay. And you do this. And I'm going to try to keep that there. And of course it didn't do it. I was trying to keep that there with my thumbnail, but that didn't work. And okay. So I actually did get the screwdriver in on the other side, and it did what I wanted it to do. Now I'm going to take this apart. Now this cover is sort of held on by the spring. But here's the fun part of this. It's these little guys. You notice that one of them decided to stay in here, and one of them decided to stay in there. And trying to just get a little bit of light on there so it's obvious, and I can't tell in my viewfinder. But the contacts in this thing are decidedly black, and the front ones are almost all black. I'm hoping you can see that. I'm afraid it's just washing out in the camera with that flashlight, so we'll part with that. So what I'm going to do is I'm going to put these back. Actually, what I think I'm going to do is I'm going to put these on here after I shoot this with a cleaner, and after I use my the tip of my small screwdriver. Is this one of the ones that is beat up? My poor screwdrivers have been abused too. So I'm going to shoot that with a cleaner, and then I'm going to gently clean that with the side of the screwdriver. Try to remove the excess grunge from there. And then I'll test it once I get it back together with my VTVM, because I want to make absolutely certain that I did indeed cure it. And then these guys are going to be even more fun because they have 2 sets of these, not just one. So the stem is going to be longer, and they'll be set here and a set there, and they're going to be a joy to get back together, I can already tell. Unfortunately, there's absolutely no way to get inside these to clean them, short of opening them up. So I'll get back to you when I am done. I have a saying, Murphy was an optimist, and this proves it. I didn't have as much trouble with the other 3 as I did with this one. Now, theoretically, let me just move this around so you can see the... Oh, come on, cooperate here. Alright. So now here we are. Let's see, ohms adjust, still drifting on me. Are you drifting? Let's go. Come on, cooperate. Okay. Alright. Now, I have not tested this since I put it back together. So you and I are going to find out together whether or not this is okay or not so okay. Let's see here. And why are you doing that? Because you can. Oops, 0. And this is definitely not cooperating either, is it? Maybe my little battery powered unit would be better for this. Alright, so that looks good. That looks good. Here. And that works good. Let's go here. It should be closed. It is. Yep. And there. Good. Fine. And then we get to this. That means that all of my little connectors have gotten in there just fine. And you can tell by the response to the meter that they're no longer dirty. Now I am going to because I couldn't get the backside of those, and there is cleaner in there. I did shoot it again, but so this one, what I did, and I don't know why different techniques work at different times. I left a plastic cover captured under here, and was able to use this cover to shove the spring out of the way a little bit. Then I was able to move this in and out and verify that it was moving smoothly. Then I was able just to drop this down and snap it in, and it worked. The other one I tried that with, not so much. But you can try it both ways, I guess. because this worked perfectly. I got this part, this long piece that goes inside there. I gently moved it over the connectors, got it moving freely, it seemed good, so then I said, I'm going for it, snap this on, and away we go. So, the next thing I'll be looking at will be the power switch and what I did to get around the problems I had with that. And I'll explain that in more in detail when we're actually in that section and looking at the power switch and what I did for it. But I do have another set of switches which I'm really reluctant to even touch, because those type are hit and hit again and release. And you can see in the top of this, on this part and up in here, there's a mechanism that there's probably a small spring in there, and there's a little arm that probably switches from side to side. So I'm really reluctant to go in there. So what I may try to do, I'm going to test the switches first, but what I may try to do is maybe pry this up a little bit, try to get some cleaner in there. So I really do not want to mess with that. These were fun enough. So, see you in a few. Okay. This was not fun. I don't know if you can see, or if I can help you to see. Inside of these, oh, stop tilting on me. Alright. Okay. Inside of here, you see little blue arms. Well, they have a certain orientation that they must have. You get one of these wrong, the whole mechanism doesn't work. How this mechanism is supposed to work is you hit one button, it releases another, and so on. So only one button at a time is latched. The other fun part, and I don't know if you can see that. Let's see here. I'm trying to... I think, well, I don't know if you can see, but right inside there is a very small spring, and there's a, let's see, can I reveal this? Yeah, okay. Alright, I think you might see it. There's a little tiny spring down there, right there. And there's an arm that runs the length of this, and on each end of the arm are these little plastic latches, and you can see one poking out there. Those come up off from the metal. There's a flat metal plate that runs the length of this, and on next to each of these switches there's one of these little flat arms that sticks up. And there's spring tension on this thing always to keep the keep at least one of these switches latched. And so far I've managed to get one of these turned around, even though I know which way they're supposed to go. These little blue gadgets right here. And the order of the switches, I had the long ones here and the short ones over here. And as you can well imagine, that did not make my day. I had to take it all apart and swap the switches around so that the right switches are in the right order. So, why am I showing you this and whining about all this? If you really think you want to take one of these apart, I'm not going to tell you not to, but I am going to tell you to set aside several hours worth of fun to get it all back together and working. Between cleaning the switches, assembling this crazy thing again, it's just not a lot of fun. So, just a word of warning to anyone who wants to tackle something like this. Think twice. If there's any other way you can get this to work properly, do it. I'm really beginning to think that, come on, I'm noticing that this isn't quite tight, not where I want it to be. Okay. And, come on. Making sure all the switches are tight, that they're not going to go anywhere. I don't think I would take one of these apart again, because it's just really miserable to get it back together properly and get it to work. I was beginning to wonder if I was going to get this to work. But I got it. And I was so close to losing the little spring several times, till I finally got smart and put a little dab of grease on one end of it. You won't be able to see that, but on one end of this thing there is a little bit of grease that I put in there, and I just... Okay. So, I'm going to assemble this, and then we'll, like I said, we'll look at what I did to solve my power button problem. Okay, this is back together, and I decided, alright, this is the switches. These are the switches that I was working on previously, and you can see how much fun it is. I started using solder wick to remove the solder, and I decided it was just too slow, because there are a lot of things to unsolder. So I got my solder vacuum out, and that worked a treat. That really got it done quickly. Made me very happy. I didn't show you putting this back together. Seemed like Murphy was having a party at my expense, and with the way things were going, I did not think you needed to see my frustration in trying to get this back together. This is kind of a very simple diagram. This is where the knob goes. This is the tail end of the switch. The little contacts are inside this plastic bar, and the tail end of this bar blocks the drill from hitting anything inside that you're going to hurt. And I started out with a larger drill bit and realized it was too large. Switched down to a lower size drill bit, and lo and behold, I didn't have to worry about stuff going inside the switch, because it just pulled all the plastic out in a nice little curly cue, and it was easy to remove, and it worked well. So these switches I tested in circuit, and they were not healthy either. Now, I could have left these alone, because these do functions that I don't use very much. These are all having to do, I don't even know if you can see without the light there. Let's see. Alright. These all have to do with tape controls, and you've got monitor and 1 and 2. You can monitor different tape decks. You got dubbing controls, so if you're copying from one tape player to another, if you have 2 of them. But not knowing what I would be doing in the future, I decided, well, I guess I'm gonna clean these up. And 3 out of the 4 were not healthy. So I drilled a hole through the back end. I shot them with cleaner. I operated them quite a bit till I was happy. And then I put my favorite stuff to seal up the holes I made. This says silicone 2. Now, the reason I use that is because it's not damaging to, it doesn't off-gas damaging chemicals that would probably undo with my work of cleaning these contacts. It does not corrode metal. It does not cause problems that the previous version of silicone would give you. So I drilled out 3 of them, shot them, worked them, sealed them with silicone, so they're back to the way they originally were. And I have to say that this was definitely a whole lot easier and probably a lot smarter. I didn't really know how they were made inside. I didn't know what I'd be getting into. So it was a good learning experience. So maybe someone else can learn from me. That's kind of the goal. Now, the other thing that I mentioned with this stereo is that the on-off switch, which is right here, and it didn't. This had better be off. Unplugged, yes. Okay. This is the on-off switch. Get the camera in the right spot would help. Okay. And one thing I want to point out, and one thing that you really need to think about if you're working on this old stuff, this stuff is all live. The fuse holder, these wire wrap pins, it's all hot. So if you're playing around in this, unless you're just trying to get voltages or something like that, unplug it, because that's what I have found myself doing, just cleaning inside or checking out components. It's hot here, it's hot over there. There's hot stuff everywhere in this thing. So, and this isn't too bad. This is your 30-volt line over here, and other power supply, other power stuff. But anyway, this old stuff was not designed the way the modern electronics is. But here's the point that I want to make with this. These switches fail, and you can't find them. I hunted. And the thing is, I'm not sure even new old stock would make me happy. Now, this is a 1980s, early 80s vintage. I think it was in 84 they bought this, I think. But somewhere around there, 85, somewhere in that range. So it's been around for a long time. But this switch started failing far sooner than I would have liked. So for a while this thing sat on the shelf, because what it did was, well, first the switch would turn on when it felt like it and turn off when it felt like it. Now you jiggle the switch, and then finally eventually it would turn off. One day it failed in the on position, which was the best way for it to fail, I guess, but I wound up using a power strip and using the switch in that to turn it on and off. And that worked until I moved all my electronics onto a different shelf, and I'd be turning everything off, and I decided that just was annoying. So I debated about what I wanted to do. So for a while I was using another stereo, because that one had a working on-off switch. But I pulled this out finally and opened it up and found out that the contacts inside this thing had welded themselves together. So I carefully separated them, filed them down, and got the switch working again. But my concern was that this thing was going to do the same thing it had done before, especially since the copper plating on the contacts was no longer there. It was just brass. So I knew that wasn't going to be a long-term solution. So what I did was I bought one of these. This is a relay, and it keeps getting washed out by my light. This has a 120 volt coil. Yeah, talk. This has a 120 volt coil in it. The contact's rated at 10 amps. This thing is rated at what? It told me how many watts, and I never did figure out what the 340 watts. And my brain is not going to figure that out right now, but it draws a fair amount of current. Not 10 amps, of course, because it'd be 1200 watts. So this relay, which is down here, is way overrated, of course. It's double pull, double throw, and I used my favorite tool, silicone, to anchor this down to the bottom of the case there. And I did that because if I ever wanted to pull that relay out of there, you can do it. You could just pry it loose with a screwdriver and it would come off. And you know, I heard at one point that if you use a relay that's overrated, that the contacts won't properly clean themselves and that the contacts can fail. I've been using this for, oh, how long have I been using this now? 6 months or more? Maybe close to a year since I replaced this setup with this. So far it's working fine. But here's the thing, if this side fails, I got this side. And if that side fails, then I've got more relays I can buy. And the thing is, they are available. This is not. So here's what I did. Now when I first took this apart, I didn't realize that lamp is washing out everything on me. Alright, I guess you can see that. In here, these two wires go to a thermal switch which sits under this case and against the frame, right against the transformer. And when I first took this off, I took this panel off, not realizing all I needed to do was take the top 2 screws out and everything comes apart. So I spotted this and I knew what it was. It was a thermal switch. And that was a good thing because I needed to know that was there, because this is what I did. Okay. I have 2 diagrams here for the old stereo. And when I took this apart the first time, I didn't remember that all I needed to do is take off the top screws on those wooden side panels to get the top cover off. So on the left hand side, which turned out to be a good thing I did, I took the entire panel off. And I found, excuse me, I found a thermal switch hiding under there. It's right against the frame, right up tight against the power transformer, and I guess if the power transformer gets a little too hot, that triggers shutting down the unit so you don't fry your transformer, which in this day and age probably is very hard to get. So this is how it was wired up. The on-off switch goes to, and there's a circuit trace on the little circuit board that it's sitting on that goes down to the switch outlet and goes out to the power transformer into the through the fuse here. So what I did was I cut this trace right here and I rewired it like this, and you notice that I made sure that the connection is made after the thermal switch. This is what feeds the coil. So the brake excuse me, so this part comes after the brake, and what you see here comes excuse me, before the brake. So this little section of circuit material, circuit trace, I soldered a wire leading to the coil of the relay and hooked it into the wire onto the wire wrap pin, which the wire from the thermal fuse was hooked there as well. And then on the other side of that cut trace, I just soldered to a soldered connection somewhere there and fed everything out to where it used to go. So what happens now is you turn your switch on, the coil of the relay is activated, it turns this switch on, and your stereo turns on. Fairly simple, fairly straightforward. Probably didn't require me to show you this, but the one thing I did want to highlight was this little deal right here. If you have some kind of a safety built into your electronic device, you've got to know where it is, because I could very easily have connected this somewhere here and I could have bypassed this safety switch, which means that if it overheated and this opened, this was going to stay energized and the thing would continue to function until it melted down. So I'm glad I spotted that. Would I have gone to the other side of that? Well, the closest connection was this side, so maybe not. I'm just glad I did notice that. I knew what it was and what I had to do to avoid not shorting this out by this relay. So it works great. The contacts on this on-off switch originally had chrome plating on them. It went bad, of course. The only thing I could do was file it flat again so that the switch would actually work and not fry. But now you've got brass contacting brass in here. These contacts no longer are using the harder chrome surface. So I knew it was only a matter of time before this switch either melted or welded itself back together again, and it would. So now this switch's only job is to turn on this very low current coil, which I'm assuming would make these contacts, brass though they might be, last for a very long time. I might have to go in there and clean them up some years in the future, who knows. But I'm thinking they would still be good enough to use after I clean them up. If I hadn't done this, I have a very good suspicion that they would have fried and permanently gone away. So if you have something that has a failing on-off switch, this is one option for you. Just stick a relay in there, and I've been using this, I think, how long? 6 months, a year? So far, so good. It works perfectly. You can't tell that I've made this difference. When you hit the switch, immediately it's on. Because, relays, they respond. The minute they get power, they're on. Click. It's not much of a delay from actually using just the power switch. You'll never notice it. But what you will have, and what I have, is a great deal of confidence now that my on-off switch will last me for a long time. I really like the stereo. I don't want to get rid of it. I also know that I can't find one of these switches. It's just they're just not available. And that, like I said, and I'm probably repeating myself, but even if I found a new old stock, I would question whether or not it was going to be any good for how long. I think this was a weak part of this setup, this stereo. I used to work on servers, so my brain's still wired that way. I was starting to think about it, and I think this thing draws about 3 amps of power, 360 watts, so that should be 3 amps, I think. So it's not a high current draw. I mean, it's a fair amount. And this is a 10 amp relay. And I know it's 7 amps below, or it's 7 amps above what the current going through it is. So the contacts may go bad on this because, like I said, I've heard that these contacts work best if they have a voltage, or current rather, that's closer to their rating, because then the contacts can clean themselves better. But, worst comes to worst, it's double throw. I move everything to the other side of the relay. I take the relay apart and clean it, whatever. What's really nice, though, is that this is replaceable. This is not. So, if that helps somebody else out, I hope it does, actually. I just hope it helps somebody. And so, like I said, it's a good way to be able to start using your vintage electronics with its failing on-off switch without having to worry about that failing permanently and not being able to find it. Now, a little bit about this thing. If I remember right, this thing was about 65 watts power, and it sounds really nice. It does have a lot of power. I was using a Panasonic, which was probably half this amount of power. And I'm not a big person for having to have the highest powered sound system. Obviously, 65 watts to some people is inadequate. This thing will put out quite well. And as I found out, it can also take out speakers. Our daughter decided she was going to sunbathe outside the house cranked the stereo, this one, to max, and went out to sunbathe, not realizing that the speakers I had attached to this were not designed for 65 watts, and she took out both tweeters. So that was not ideal. But this is just a quick picture of the inside of this. It's not a super high-end, might be middle of the road. I'm not an expert at this stuff, but it's got some decent features in it. I mean, it does have what I believe to be a temperature sensing transistor or device of some sort that will probably regulate the bias based on the temperature of this. It's fused, obviously. You know, it's got a really nice heatsink. I was playing this earlier, and this heatsink didn't warm up at all, and I'm guessing that unless you're really cranking it, that it isn't going to heat up, because that's a lot of heatsink. But for what it is, it's a decent unit. The one thing I have heard is that the FM section can go bad on these. This one is from 84, 85, somewhere in there, and I've never had trouble with that. On-off switch, yeah, that's been my problem child, but and of course, as it aged, all of these controls are just getting dirty and corroded, and so I'm going to actually fire this thing up. I think I'm ready to go. Watch my volume. Let's see. Wait through that. Go through that part. There's my turntable over there. Okay. So you can definitely hear it's got some good bottom end. It's super crisp because my KLH speakers, the tweeters I put in them were probably the wrong ones, and so now they're extremely high frequencies are extremely good in those. But I have some Optimus speakers there's one of them over there, and those sound really, really nice too. Three-way speakers, lots of bottom end. It's a more rounded sound though than the KLHs. Those are two ways. And while they've got scads at bottom end and really good in the highs, the middles are, yeah, they're okay. So anyway, this thing is now just going to go back together and go back into service. Now that everything's working, the thing that caused me to take this apart again, because I did the relay a while ago, and then I wound up doing this, was this switch right here, because I was playing my records through it, and I kept wondering why the one channel kept dropping out, and I thought this was the balance controller. That's what this is. And while it was a bit dirty, that was not my problem. It was right there. So it's just the nature of the beast. I learned a few things. Hope you did too. Thanks for watching, and hopefully I'll see you next time.